We move on to question 10. It reads as follows. The ratio of girls to boys in a chess club changes from 2:3 to 5:6 when 6 girls join the club and 3 boys leave the club. If n was the number of boys before the changes, what is the product of the digits of n? All right, so I want to look at girls to boys. So the ratio of girls to boys is 2:3 in the beginning. So let the number of girls be, we can't say 2, we will say 2x, right? And the other one will be, in boys, be 3x. If the ratio is 2:3, then we can say that the actual number is 2 times something, and the of girls and the number of boys will be 3 times something. Okay, so now what happens now? 6 girls join the club. So that means the number of girls has now become 2x plus 6. And 3 boys leave the club. So you had originally the 3x, and then when 3 left, you got 3x minus 3. Right? And now this new ratio is now becomes 5/6. Okay, so when this happens, the ratio becomes 5/6. We have one unknown and we can solve. All right, let's just cross multiply. 6 times 2x is 12x. 6 times 6 is 36. 5 times 3x is 15x. 5 times 3 is 15. Bring all the x's to one side. I'll put 15x minus 12x. I'll bring all the x's to the other side. And then it's 36 plus 15. And that means you got 3x is equal to 51. So x is equal to 17. Right, but we needed to know the number of boys before the changes. So n is the number of boys. And we said the number of boys is 3x. And before the changes was 3x, and x is 17. So this is 51. Okay, so this takes care of from question 10. Oh, so n is equal to 51. The actual question was, what is the product of the digits of n? So one has to answer the question. Sorry about that. So it's 51. The product of the digits will be 5 times 1, which is 5. Okay. So let's move on to the next question. This is question 11. Question 11 says, every student at a certain college selected one language, either Afrikaans or isiZulu, and one science subject. So they couldn't do Afrikaans and Zulu, and they couldn't do chemistry and physics. They have to choose one from the 2 languages and one from the 2 sciences. So you have lots of information that is given. 60 students chose physics and isiZulu. 100 students chose chemistry, and twice as many students chose Afrikaans as those who chose Zulu, and so on. So you got all kinds of information. We have to put them together And normally we draw a Venn diagram, but I have to admit that when I use a Venn diagram, it didn't help at all. See, we have to say that Afrikaans and isiZulu are separated because uh, nobody does both of them. And likewise, you have to say that physics and chemistry are separated. So we put Afrikaans in one lot, isiZulu in one lot, and here it means those Afrikaans students who chose physics and those Afrikaans chose chemistry, and likewise for the isiZulu students. So these represent the different parts. And if you add all four, it'll give you the number of students in the school. That was the question. How many children are there altogether in this college? Okay, so everyone does one of these. They say they belong to one of these. So therefore, you'll have to add up all the numbers. Okay, so where do we start here? There's 60 students chose physics and isiZulu. So if I so you got physics and isiZulu, there's 60 here. So let me put it, I'm going to put it down in the slot here. 60 students. 100 students chose chemistry. So we don't know how many in each of them. So you got the chemistry is here and here. And suppose you got X Afrikaans students chose chemistry, and then there were 100 students altogether, so it's 100 minus X on this side. So altogether, X plus these 100 minus X will be our 100. So we finished with this, we finished with this. Twice as many students chose Afrikaans as those who chose isiZulu. Okay, so how many people chose isiZulu? You can see here, you got 160, 60 plus this. So the total here is 160 minus X. But there are twice as many students who chose Afrikaans. So you've got 160 minus X who chose isiZulu, and altogether you've got 320 minus 2X. Twice as many students chose Afrikaans. So the total number here is 360 minus 2X, and therefore this part here will be 360 minus 3X. And when you add these two, you're supposed to get to that. So now we got each one of them. And how many students were in the school? Oh, that's the thing we don't know, man. Oh, we got 120 students selected either physics or isiZulu, but not both. So if they chose either physics or isiZulu, you had 120 students. So it means that so these people chose physics and isiZulu and isiZulu. So we are looking at these students as either physics or isiZulu. So here, these are students who chose um, physics, but not isiZulu. Right, okay. So these are students who chose physics, but not isiZulu because they're on this side. And you will also have these people here who chose isiZulu, but not physics. So in other words, these two will add up to 120. So you got 360 minus 3x, that lot, plus 100 minus x. This lot here will be 120. Okay, so what have you got here now? You got, take all the x's to one side, 3x plus x is 4x on the other side. And here you got 360 plus 100, which is 460, minus 120. So that makes 35. 460 minus 120 give you 340. Okay, that means x is 85. Okay, so x is 85. So the 85 students here. So altogether, you have these two add up together. It's the total number of students. Is equal to, if you add these two, you have 360 minus 320 minus 2x plus 160 minus x. So that gives you 320 plus 160 is 480 minus 3x. Okay, so that's the total number of students. And you had 3x is 255. Was that the question? Just one moment, please. Let's go and look at the question. I forgot what the question was. How many students here? How many students are at Atholl College? So we're going to add up the whole lot. And that gives you 235. $225, I think. Let's just see here. 60 students chose physics and isiZulu. So I got 60 is right here. 100 students chose chemistry altogether. So if x were here, then this is 100 minus x. Twice as many students chose Afrikaans. Okay, that's okay. Now here you got 120 students selected either physics or isiZulu. So they selected either that or that. So I think you're going to have either physics or isiZulu. I think you really had to add physics, the total number here and the total number here, but not both. All right, so that's right. Physics and isiZulu, but you're not allowed to be here. So it's physics plus chemistry. And that gives you 360 minus 3x plus 100 minus x. That's 460 minus 4x. All right. Somehow, let me just see what the answer is. According to this, my answer is 225. Somehow I don't remember that one. Let's look at what the actual answer is. Okay, okay, now that's fine. I think I add all these numbers. I can see quickly add all those numbers, so that's okay. And then so it's 320 minus 3x plus 100 minus x. Yeah, so it's 320 minus 3x plus 100 minus x. Yeah, that's what I said, equals 120. So what went wrong here? This is 420. Well, I think I had 360 here. 360. So yeah, twice 160 minus x. Right? Twice this is 320 minus x. Sorry, 320 minus 2x. Okay, I think I had 360 here. So that's why I went off. So it's really supposed to be 320 minus 2x. And then eventually your answer is 255. Okay, so these calculations, one has to check and recheck the calculations. And this is a lesson. Hopefully you will learn from my errors, because we have to check to see whether our calculations are correct, and my calculations were not correct. I said twice 160 is 360, which is blatantly false. All right, so let's just go on to the next question, which is the following. Question 12. What is the largest possible area of a triangle with one side equal to 7 meters and the other side equal to 14 meters? So that's the question. So you got a triangle with only two sides are given. One is 14 and the other is 7. So let's just see. 14. Suppose I put 14 down here. And the other side is 7. So only two pieces of information. You're not given the third side. And you want to know what the largest possible area is. Okay, so what we have to do is to see where the third point is. The third point is 7 units distance, say from here. So it's 7 units from this point. But it could be any point which is 7 units from that. So in other words, the third point lies on a circle which has got this center and radius 7. So that way I know that all these points are candidates for the third point. So let me draw such a circle. Hope I can draw the circle. I can draw it rough hand, but good. Somehow I never was able to do this. Okay, so it's like that. And so your point, oh no, wait a minute. This has to be the center. Yeah, the center is at this dot. So it's there somewhere. So your point, the third point of this triangle is somewhere on that line. So if this is this radius is now 7. So you could have the third point here maybe, right? Or here, or here, or here, anywhere, right? But they tell you the largest possible area So what is the area of this triangle? If the point P was here, then the area of the triangle will be half base times the height. That's the area of a triangle. Half base times, and the height will be from here to here. The base is already 7. So that's non-negotiable. The area is equal to half base, which is 14, times the height, h. Now you want the largest possible area. So you want h to be as large as possible. So for the various points P, you can see the h from here, as I move from left to right, the h is getting bigger and bigger and bigger until it comes to here, the North Pole, and then the h gets smaller. So the largest possible area will be where the point is right at the North Pole. So, and of course, at that case, the thing will be a right angle here. Okay, so the highest point, and that h is maximum. So therefore, now you want to know what the area of this triangle, but now is this a right angle triangle? You see? And the area of right angle triangle, half base times height, the height is now 7 because that thing is perpendicular. So the area is 7 times 7, h is 7, and that gives you 49. So this is the largest area. Generally, the area is 7h, but the largest one is when h is equal to 7. You have to put square, or the units are given, so it's square meters, square m. Okay, so let's just check to see. I think this is right. So you can see at the bottom of this, you can see the 49. Okay, so that is the correct answer. So let's proceed with the next problem. Problem number 13. So problem 13 says a number is placed in each box of the grid below. There are 9 boxes there, as you can see, and 3 numbers have been placed. And there's a question mark there also. It seems that you have to find that particular number. Now, the sum of the 3 numbers in any row or column is the same. So in other words, when I add those 3, it's the same as that, the sum of those 3, any row or column or diagonal. So you're allowed to include the diagonal. That sum is the same as that sum. Okay. So now the question is now, what is this? What is this number here? Okay, I can see 2 numbers in this diagonal. So I can work out the third number, but I have to say what the sum is. So let S be the sum. I'm not letting the unknown be one of the numbers in the square. I'm letting the unknown be S. And the reason for that is I've got 2 numbers here. I've got 12 here. So these 3 numbers will have to add up to S. So you'll have to put an S here. And 8 plus 4 is 12. So it has to be minus 12 here. So When you add these three, you'll get S. Okay. All right. Now here too, when you add, oh, I see. Yeah. So you can get the answer straight away because you got two numbers here and the three numbers add up to. So that this these three numbers add up to S. So you have to take S minus the sum of these two. This is S. So 7 plus S minus 12 is S minus 5. So what must you add to S minus 5 to get S? The answer is 5. So the answer is obtained straight away. We don't even use, no, I've used this. I've used all three numbers. All right. So the answer is 5. When you simplify this, you're going to get 5. Okay, that was quite an easy problem. But there you have to say the unknown is S. I tried using the unknown as X, so let the middle number be X. It took me a long time to eventually come to 5. Then I got the entire thing. But we didn't need all that. You only needed just a question mark. Okay, so that takes care of that problem. So there it is. The answer is 5. You can see it there. So let's now get on to question 14. Consider a set of all possible 4-digit numbers you can make using 6, 7, 8, 9. Now these are 4 different numbers, and you can make, how many can you make like this, right? When you count using my method of counting, the way I do it is the first number can be chosen in 4 ways, any one of these 4. And the second number, 4 ways of choosing this. And once you choose the first number, not allowed to choose it again. Repetition of the digits is not allowed. So the second number can only be chosen in 3 ways. You can't choose the very first one. So the first 2 numbers can be chosen in 12 ways. For each choice of the first, you got 3 choices of the second. Right? The third number can be chosen in 2 ways. You're not allowed to choose either of these. So therefore, the first 2 can be chosen in 12 ways, but the first 3 can be chosen in 12 times 2 ways, which is 24. And of course, once you choose these 3, then you got no choice but to put the last one in. So there are 24 such numbers. Okay, or 4 factorial. Right? The number of ways of arranging n numbers, number of ways of arranging n objects is n factorial. It's a very important fact. Right? So I could have done it straight away. I said, okay, the number of ways of creating a 4-digit number here, all the possible different arrangements, that will be 24 of them altogether. Okay, now they want to know what is the sum of all the numbers in S. That's quite a handful. Okay, let's take, maybe we have to have some system in counting this. Let's put from largest to the lowest. 9, 8, 7, 6 is the largest. And then you keep coming down, 9, 8, 6, 7. And then you'll have 9, 7, 8, 6, and so on until the very last number you come to is 6, 7, 8, 9. I'm just doing it like this so that you keep track of all the numbers, you don't repeat anything. Now we're going to add up all these. Now you'll say, what kind of problem is this? We don't, I have to write down these 24 numbers and add all of them. How can I write 24 numbers? That'll take me a long time. So you have to think now, what's actually happening here? There are 24 numbers, right? In each column, there are 24 numbers. And you will agree that the number 6, how many times can it occur in the 24 numbers? All these numbers have got equal chances of appearing here. Nothing very special about any one of these 4 numbers. So if there are 24 numbers, all will be given equal status. So it means that there will be 4 sixes and there will be 4 sevens. Now wait a minute. 6. 24 divided by 4 is 6. So you got 6 sixes and 6 sevens. And likewise, you got 6 eights. And 6 nines. That'll make up the 24. Now that I can add because the sum here is 6 into 7, 6 plus 7 plus 8 plus 9. 6 of each. That 6 and 7 is 13. 13 plus 8 is 21 times 9. 21 plus 9 is 30. 30 times 6 is 180. All right. So all these will add up to 180. Likewise, even all these, the first will add up to 180. The second one will also add up to 180. Third one, and so on. So if you're adding, then you have to keep carrying over, but you don't really have to do it like that. You can say that the 180 here in the 1000th column and there's 180 in the 100th column. So they will represent 180,000 and likewise 180 in the 10th column. And then 180 in the last one. We saw that'll add up to 180 here, right? So you're adding all these, the 180 thousands and 180 hundreds and so on. Okay, so you actually have 180 is a common factor into 1,000. You're getting that number because these numbers occur in the 1000th place, one in the 1000th, one in the 100th, one in the 10th, and so on. And this gives you have to multiply all these. And I think I can actually multiply it because it's an easy thing to multiply. Or you can add it. It's easier to add it. So you get a 0, certainly a 0 at the end. And you get 18 times this. I think that's 1,998. 18 goes in this 1, 1, 1, 1. Okay, so you've got, that's the the sum of all these. I think that's the answer. Okay, it's a nice problem because without even doing the calculation, you're just thinking to us, we sort of think, how can we do this quickly? Then you make the observation that there will be only 6 of each of these in each of these columns. And that is a great help. So let's just check to see what the advertised answer is. Oh, there it is. Right, exactly the same thing. Okay, now we get on to the last question. I think question 15. Okay, before going into question 15, I thought we'd just mention an important theorem. The last question is quite hard, I'll have to tell you. And you need to have some theorems, this particular theorem at your disposal. It's a very simple theorem. It's a theorem that is given in grade 11. And I know it's not fair to you guys who are in grade 8 and 9. But you remember, this is this is a team competition. And yeah, you got teams from right across the country are taking part. So you have to identify the best ones. So you have to give some difficult problems so that it challenges everybody. But a good student will also know theorems like this. See, like I've told you, if you've been watching my other programs, there are some things which are in grade 11, grade 12 as well, that I discussed so that to solve the problem. So you have to, you are given knowledge. Now I'm going to give you some more knowledge on a triangle. You see, when you got a triangle, you got a line which is parallel. Any line like this parallel, it divides these two sides in the same ratio. See, the ratio of ax to xb is the same as ay to yc. They're the same ratio. Of course, ax to xb is ax over xb, and ay over yb. So this is important. And then conversely, if you know that this over this is equal to that over that, then this line will have to be parallel. So just remember that. A line parallel to a side of a triangle divides the other two sides in the same ratio. It's sort of intuitively obvious. So if this point was the midpoint, for instance, if x was the midpoint, then the ratio will be a half. Ax is to xb, then that ratio will be 1. So if this was the midpoint, that ratio will be 1. So this other ratio will also be 1. This will also be 1. So ay equals yb. So if x was the midpoint of ab, then y will, and this line is parallel, then y is the midpoint of that. Now that's also a theorem, the converse to the midpoint theorem in geometry. So this is a little bit more general. It tells you no matter which line you draw to parallel, this ratio will be the same. Okay, with that long story, oh yeah, I've got this is quite useful also. If you got a parallelogram, this thing here is a parallelogram. You got a triangle inside, which has got the same base as a parallelogram. The base is a side of the parallelogram, and the third point is on that other parallel line. Then the area of this triangle is half base times height. That's the area of a triangle. But the parallelogram is the area of a parallelogram is base times height. So this is the area of the triangle is a half the area of the parallelogram. So whenever you got a situation like this, you must know that this area is half the area of the parallelogram. As you can see, the formula tells you why. All right, so bearing all that in mind, let's get into this problem, which I told you is quite a difficult problem. Okay, in the diagram below, actually, this is the diagram that was given. This one here. The tilted square ABCD is inside another square. So this is a square and it's inside another square. It's a tilted square, right? The side length of ABCD of the tilted square, the side length is 4, they say. And what is the area of this shaded region? Okay, now you got a funny region here. See, what you do is you take one vertex of the tilted square and you join it to a vertex of the original square, get a line, and likewise, you got a vertex of the tilted square is joined to that vertex. Right? Now, when you join that, you got this figure here, and you want to know what the shaded region is. What is the area of this green part? Okay, now before we proceed to that, I just want to make some conclusions about this tilted square. Now listen carefully. There's a lot of nice geometry here. Okay, I've put in all these figures, but just imagine that originally we had this. I'm going to redraw this. What happened there? Sorry. So I'm going to draw a square. I'm going to avoid all these symbols. I'm just going to draw the square. So you have okay, not bad. Okay, so what can you conclude here? The large type thing is a square, and so inside is also a square. Now, because it's a square, then all the sides are equal. So let me just put that down. Right. Now you notice now that the outside consists of 4 triangles. They are all right angle triangles. And their hypotenuses are all equal. It actually turns out that these triangles are congruent. See, apart from just the hypotenuse and the angle, you got something else. Like for instance, if I take this point here, I call this angle here alpha. Now this is 90 degrees. And that is 90 degrees. So this angle here, oh, I'm sorry. Let's go to this. Alpha. Now this angle here is 90 minus alpha because the whole thing is a straight line. This is 90. So these two will add up to 90. So this angle here is 90 minus alpha. But in this right angle triangle, if this is 90 minus alpha, this will have to be alpha because these two angles add up to 90. So if I got 90 minus alpha, I must put in alpha here to make them add up to 90. So now you can see that these two triangles are congruent. Okay. In fact, exactly the same argument means that all these triangles are congruent. You see? Because this angle alpha will be equal to this one, and this angle here will be that one. So you have all those triangles have got the same two angles and the hypotenuse. Okay, but the more important thing about this is that if this side here is A, this is the side opposite this angle here, will be equal to the side opposite that angle, and that will be equal to the side opposite that angle, and that will be equal to the side opposite this angle. So those four sides are equal because the four triangles are congruent, and the remaining sides will be this. They will also be equal. They're not congruent, so they're equal in all respects. So that the fact that this ABCD is inside the square makes you conclude all these things. But I'm particularly interested in the fact that, you see, this one here, this diagram here, this A was this vertex, A, and that was joined to that, and this is C here. All right. Okay, so bearing all this in mind, that's what I got in the second diagram. And remember that it's given that one of the sides of this is 4. Okay, so let's just hold on with that. Now we've got all that information. Now here, let's get on to the problem at hand. What I do is to calculate this shaded area, wherever they intersect, I'm going to draw a line going through the intersection perpendicular to this. In other words, I draw a line parallel to the side here. And remember, in this diagram here now, because A was the same as that, that is A and that is B. And according to this picture here, this is A, this is B. So I've actually filled in this diagram, which didn't have the A and the B. And this A and B are sides of this right angle triangle. Okay, so we'll just reserve that. Now I want to find the area of the shaded region, and I perform this construction. I draw this line parallel, which will mean that this is 90 degrees, and this is also 90 degrees, yeah? Okay. Now comes the tricky part, namely the xy. I want to prove that xy equals A. This xy is equal to A. All right. So I don't know what xy is. So let's call it P and call this Q. So I must now try to prove that P and A are the same thing. Now, here comes the geometry. I'm going to look at A over B. Now, these two triangles are similar. They got the same angles. These are vertically opposite angles. They are equal. And this angle here is equal to this angle here. These are alternate angles. Likewise, these two are also alternate angles. So these two triangles are similar. So A over B A is a side of the yellow triangle, small triangle, over that will be equal to the other ratios. The ratio that I want to look at is the ratio which is opposite curl. The opposite curl, I've got XO. And opposite curl here, I've got OC. Now, this is all about similar triangles. Two triangles, if they got the same angles, then their corresponding sides are in the same proportion. So I've just taken the corresponding sides. The side opposite that is A. The side opposite this equal angle is B. So that is how you work the ratio of the corresponding sides. Now if you turn your attention to XO over OC, this one here, you see in this triangle here, XZC, this large triangle, I got O is a point on XC, and this line is parallel to this line, right? Because these are 90 degrees, 90 degrees. So co-interior angles or corresponding angles are equal. So therefore, these two lines are parallel. Okay, and I just told you that this is the same. This is the mean proportion theorem. I got XZC is a triangle, and I got one point on one of the sides, and I got a line parallel to this. So therefore, it means that this ratio XO over OC is actually equal to P over Q. That over that. So this over this is P over Q. Okay. Now, if two fractions are equal, you've got A over B is equal to P over Q. And we've done this before. These are equivalent fractions. A is not equal to B, but B is equal to something times A. Call it A times M or something. And Q will also be equal to, no, this is P, I'm sorry, P. P is equal to AM, and Q is equal to the same M times B. So we can make this thing AM over BM, right? And you can put M as any number whatsoever. So AM over BM will be equal to A over B. So therefore, P is equal to AM for some number. We don't know what it is. And Q is equal to this. All right. Now, you see, I know about P plus Q is equal to A plus B, you see. Because these are two sides of the square. So they are equal. And now P is equal to AM plus BM. And here you have, this is M into A plus B. M comes out as a common factor. So what is the meaning of this? So A plus B is equal to M times A plus B. And that means that M is equal to 1. Because A plus B is equal to M times A plus B. If you cancel, M is equal to 1. And you go back to this, and there you have it. That P is equal to A. M is 1, you see. P equals A. And also you've got Q equals B. Right? Now, that is your XY, you see. XY is, we named it P. So the question was, I told you that I'm going to try to prove this. See, it took a long time to get to that. So in place of the P now, I can write down A. We just proved that this is equal to A, and we proved that Q is equal to B. Okay. So now, what do we have? We have the following. I'm going to create some space here. If you look at the middle diagram, we can now calculate the areas of these triangles, the shaded area. So shaded area is the area of the small triangle here. Right, now watch very carefully. This triangle, what is its area? If I take this as base, so it's half A, that's your base, times the height. The height will be the distance from this point here to this line, but that's exactly the same as that one. These two lines are parallel, you see. Okay, so the height is the same as that height. So this is like that. Or if what I told you earlier on, that the area of this triangle is half the area of the parallelogram, but this parallelogram happens to be a square. We'll go A times A and all these 90 degrees. So that's how you get half A squared. Okay, now that's the small shaded area. This large shaded area is half again. Now again you got B base, and the height of this is the same as that. The same as B again, right? The height from here to here is the same as, these two lines are parallel. So they have the same height no matter where you take those 2 points in. So you're going to add these two to give you the shaded area. That gives you half of A squared. Half goes into, can be taken out as a common factor. And A squared plus B squared. Now look at this. A squared plus B squared, if you go back to this triangle here, then it's actually equal to this AD squared. Because this is Pythagoras. This point was D. So you got half AD squared. And when AD was given to be 4, you see the sides of this was, of the red square was 4. So this is half of 4 squared. Half of 16 is 8. So the shaded area is 8. Okay, that was quite a challenging problem. And we get to the answer. Now I want to tell you something else. The theorem of Pythagoras, you are told the theorem quite early in your school career, but I don't think anybody cares to actually prove it. And here I'm going to prove the theorem of Pythagoras. Hopefully, you guys are all very excited about this, because I think very few of people I know who know how to prove the theorem of Pythagoras. And this, that I'm going to prove it for you. So let's take this triangle here, triangle ABC, right angle. You got, this is X, one side is X, the other side is Y, and you want to prove that X squared plus Y squared is equal to Z squared. Right. Now, the way to do this is to draw this picture here. Right? Quite ingenious, whoever did this thing. And what does the person do? He starts with this triangle, extends this by the same length as the other side. You see, the other side is A, so extend this by Y, lands up here. Then once it's got this, it takes this and extends it. You don't have any of these red lines here for the moment. Extends it by x9, in other words, by the other side. So now you have that these two, and then here you drop a perpendicular. So now you have that this line will be parallel to this. It's got the same length because one is x plus y, and the other is y plus x. And then you complete the rectangle. Complete the rectangle. But actually, the rectangle becomes a square because this is x plus y, and this is also x plus y. So now you have a large square. And then once you do that, then you knock off on each side, you knock off. All the sides are now equal to x plus y. So I'll put an x, cut off x here, that'll be y. Cut off an x here, that'll be y. And then cut off an x here. Well, there's already y here. So this part is x. So you have this picture here. This is exactly the same picture that we had before. That's why I'm talking about this. Because now you know that for the same reason, well, actually not. You got these four triangles are congruent because this time you got side angle side. XY 90 degrees, XY 90 degrees, XY 90 degrees, and XY 90. So these four triangles are congruent, right? Which means that the hypotenuses are equal. Right, so this figure here is now a rhombus. Be careful, don't say it's a square straight away. It's a rhombus because a four-sided figure with all the sides equal is called a rhombus. But we don't know, it'll be a square if we know that this angle is 90 degrees. But watch, alpha plus beta, if these are two angles in this triangle, is 90 degrees. But since these two triangles here are congruent, this would be beta because it's opposite x. And the one opposite x is beta there. So alpha plus beta 90. So therefore, these two add up to 90. And that tells you that there will be 90. See? So now what is sitting inside here is a square. This is different from the previous problem because you got different information that is given, right? Okay, but it's the same picture in the end. The starting points are different. Now, we are almost ready. We can now calculate the area of this shaded part. Now, this shaded part is, all these triangles are congruent. So 4 of the shaded area plus BC squared. This is a square here. So the area of this square here is BC squared. And that is equal to the area of the large square. Because I got that, four of this is that plus that plus that plus that, plus this gives you the area of the large square. That is why I made this calculation. And this large square has got sides x plus y. The side of the large square is x plus y, and that's the area of the large square. By construction, this large thing is a square. But now you know what this is. This is x squared plus 2xy plus y squared. It's the square of a binomial. But what is the shaded area? The shaded area is the right angle triangle, and it's the two sides are x and y. So the area of that shaded part on the left-hand side is half base times height plus BC squared. Right? The shaded area is the right angle triangle, and we know the area of a right angle triangle is half xy. So you got 2xy plus BC squared is x squared plus 2xy plus y squared. 2xy is actually cancelled, and you're left with, now why am I calling this BC? I'm calling it Z here. So that would have been very, very, very much nicer. Okay, so BC squared is Z squared is equal to x squared plus y squared. Lo and behold, that is precisely the theorem of Pythagoras. Okay. Okay, thank you very much for listening. And that brings us to the end of this session. And it completes the discussion on the junior individual problems in the team competition of 2023. Okay, bye and enjoy the rest of the day.